Okay, boys, let's start with conservation of momentum for today's topic, work for energy. And if we say about these topics, we already knew the conservation of momentum when we read work for energy on class 9. What is conservation of momentum? What is conservation of momentum? We know that if there is no external force acting between the two bodies, then their initial and final momentum will be conserved. But if I say about this one, conservation of energy, these two things are not same. We will start from the second one, but we will compare these two, conservation of momentum and conservation of energy. Conservation of energy is separate than the conservation of momentum. Okay, please turn off your microphone. If we say what is conservation of energy, it is like that. I think everybody should write down conservation of energy. We know conservation of momentum, but we will discuss conservation of energy now. Okay. Conservation of energy. Energy cannot be created or destroyed. Everybody should write. Energy cannot be created or destroyed. It can be converted from one to another. It can be converted into one form to another form. I think that word will be proper. From one form to another form, and the total energy in this whole universe is conserved. And the total energy in this whole universe is conserved. So there are some difference between conservation of momentum and conservation of energy. Okay, so we go with energy. Energy cannot be created or destroyed. So this is the main part of conservation of energy. When you go for conservation of energy, you have already known that it cannot be created or destroyed. Only it can be converted. So if I assume a falling body, the energy is conserved on it. If I assume a simple pendulum is vibrating, also it will have conservation of energy. If I consider a spring is vibrating, also it will have a conservation of energy. So in every section, there will be conservation of energy. So what is the difference between conservation of energy with conservation of momentum? Conservation of momentum at least needs two bodies, but conservation of energy, it's an event and it doesn't need two bodies. In one body, conservation of energy can be explained. So this is the difference. But today, we will go conservation of energy for simple pendulum. We will discuss this thing. So first, I draw a diagram and then I explain the conservation of energy when it's vibrating. suppose it's a pendulum and it is vibrating in the right and the left direction. So I'm considering the one direction here, it's on the right. In some time, it will reach at this position. And I'm considering it's the equilibrium position A and its maximum position is C. Okay, so there will be also this C position will also occur in the left side also, but we will not consider the left side now. We will just discuss the one side here. Okay, so if I draw a perpendicular from point C, it will intersect the OA line at a point N. So further, I can say that the position of the pendulum bob, you know that it is called bob. Bob is called the sphere of the pendulum. So the position of the bob at point C has the equilibrium point N on OA line. I repeat again, the position of the bob at point C is the same point as N on the equilibrium line OA. Therefore, if I say what is potential energy at point C, potential energy at point C, you can say it is as mg into an. Why? Because mg is the weight which is acting downward direction, and we know from our very first class then that is the potential energy is always determined from downward to upward direction. So the downward point is A and the upward point is N. So the potential is measured as AN, which is, I'm included here. You see as mg into AN. So I make it equation number 1. And the kinetic energy at point C, the kinetic energy at point C will be 0. Why? Because at point C, there will be no velocity for the bob. The bob will be stopped at there. When it reaches its maximum position, for a very short time, it will stop at the point C. That's why there will be no kinetic energy on that point. Now, the total energy. So what is the total energy? I will add these two, UC and KC, and finally I can go like this, mg into an. So the total energy here is mg into an. Where? At point C. So here in the conservation of energy, every time we will count the total energy. And in every time we will see that the total energy remains constant. That is the conservation of energy. Okay. So if I say now the bob will go towards the point A, and in a certain time it reaches at point B here. It reaches at point B on a certain time. Now, if I draw a perpendicular from B point to the equilibrium line, just like this, it will intersect at point M. It will intersect at point M. So, now we can further say that we can say this thing. If the bob reaches from C to B point, the equilibrium point also reaches from N to M. And if it goes from B to A, then it will reaches from M to A. So it's just like a falling body. So
sir, will you repeat
it is a
again?
simple pendulum, but it falls like a falling body. Yes?
Will you please repeat the last lines again?
Saad, I can't hear you properly because your sound is not clear.
Sir, will you please repeat the last lines again?
Oh, repeat the last line. Okay, I understand that. I am saying that if the bob reaches from C to B, then the equilibrium point for C is N and B is M. So if it reaches from C to B, you can see that the equilibrium point also going downwards from N to M. And when the bob reaches from B to A, the equilibrium point will go from M to A. So it's just like a falling body. This is the last line. Okay. So simple pendulum acts like a falling body where if we consider the equilibrium position of this simple pendulum or equilibrium line as OA, then I can see this falling body nature for a simple pendulum. Okay. Now, potential energy at point B. If we measure the potential energy at point B. So you say it as UB, and we know one thing, that potential energy should be measured from downward to upward direction. So downward to upward, it means AM. So I write here AM, mg into AM, and for C it will AN. That's why I am writing mg into AN. Okay, so this is the potential energy at point B. But if I say what will be the kinetic energy at point B, the kinetic energy, then there will be some kinetic energy at point B also. And we know just one thing of kinetic energy, one equation of kinetic energy, and that is half mv square. There will be no other equation. So we can write Kb as half mv square. Okay, now we know that V square as V naught square plus 2gh. H is the height. But here, the point reaches from N to M when the bob reaches from C to B. So the height will be considered here as Nm. So V square will be 2g into Nm. So half M 2g Nm. If I say, it becomes just like this, mg into Nm. So this is the kinetic energy at point B. So you can also include this statement that kinetic energy can be measured from upward to downward direction. So we can say this line also. Kinetic energy can be measured from upward to downward direction. Okay, so if I add these two things, UB and KB, UB and KB, then it becomes EB. EB is the total energy at point B. So what will be EB here? If you add these two, mg into AM and mg into Nm, you can common mg and then you will add AM and Nm, and also you find the same thing as EC, that is mg into An. So for the both cases at point B and point C, though these points are not in the same position, but their total energy remains constant. And the total energy is mg into an. So if I say, and what will be its total energy at point A, you can find it the same, mg into an. So in every section, you will get this conservation of energy, and you can say that the energy is conserved as the particle is vibrating or an object is falling. In every section, the energy is conserved. Okay, so how we can apply this kind of theory in mathematical form? Now we will understand a mathematics here. Okay. Here we will solve a math of conservation of energy using a simple pendulum. So now we write a mathematical problem. Suppose this picture is included on the map, and I am giving further information that the mass of the bob is 300 gram. The mass of the bob is 300 gram, and also I am giving some length of it. OA is 1 meter length. BM is 25 centimeter length, and CN is 40 centimeter length. So we consider this picture as our mathematical problem, and I am writing some information here, and that information will be included with this picture. Okay, so what will be our question from this kind of mathematical problem? What is the potential energy at point C? What will be the potential energy at point C? So if I say the potential energy at point C, we have found UC as mg into An. That is correct. This is our potential energy. UC as mg into An. Okay, but what is the value of An? I am not giving you the value of N here. I am giving you the value of Cn. So An can be easily measured from this value. An can be easily measured. How? We will just solve it. Okay. First, we go for Ocn triangle. Okay, so I'm giving you the triangle Ocn. Okay, if you say OA as 1 meter, also OB and OC is also 1 meter, because OA, OB or OC, all of these are the radius of the bob. You can consider the radius of the simple pendulum, not bob actually, simple pendulum. So that's why all these distances are same. So if I say OCN, you can say like this: OC square is equal to ON square plus PN square, according to Pythagoras theorem. So here OC square is 1 square, or you can just write down this way: OC square minus PN square. So it's 1 square, and also you are given Cn as 40 centimeters, so it's 0.4 square. So what will be the value of On? What will be the value of On? Give me the answer.
0.9165.
0.9165. Okay, this is On. So if I determine the On value, I can easily determine now the An value. So here An will be OA minus ON, because AN is here. If I say it is AN, so it can be said as OA minus ON. So OA is 1 meter, ON 0.9165 meter. So what will be the value of AN?
0.0835.
0.0835 meter. Okay, now place this value AN in this equation. mg is 0.3, g is 9.8, and it's 0.0835. So you will get the answer in Joule. So what will be the answer now?
Uh, 0.24549.
49 আর লাগবে না, that will be answer. 0.2455 joule is the answer. So if you are you have to determine the potential energy at point C, you can determine in this way. Now you do this one. What is the potential energy at point B? Solve it. What will be the potential energy at point B? Because you are also given the distance BM here as 25 centimeters. So you can solve this math also. Solve it, and then I will go for another term.
Sir, you want the value of BM?
BM is 25 centimeters. So you have to get the potential energy at point B. You will consider OBM triangle. Now you consider the triangle as OBM, not OCN. It's OBM. Okay, you can inform step by step. First, what you have got.
0.093 joule.
Okay, that will be good, but we go in step by step way. That will be the what is the answer you have just told me?
0.093 joule.
Okay, just let me check. What will be the value of OM? 0.9682.
Yes, sir.
Okay, so if I multiplied it by 0.3 and after 9.8, okay, 0.09335, right?
Yes, sir.
Okay, so the answer is 0.9335 joule. 0.09, sorry, 0.09335 joule is the answer. 0.09335 joule. That is the potential energy on point B. Okay, now if I remove the potential word and place this thing, kinetic. What is the kinetic energy at point B? So you know that the kinetic energy at point B, we have just discussed one thing, that the kinetic energy should be measured from upward to downward direction. Right? When we talk about the kinetic energy, KB, you have just wrote that mg into, that is nm. You can see that kb here is mg into nm, and we have also known that the kinetic energy can be measured from upward to downward direction. So I can say mg into nm. So I have to find out the value of nm here. Okay. So how I can measure nm? I can say that it's OA minus OM, but also we can say AN minus AN. We have these two values. If I measure NM, I can say AN minus AN, so it becomes NM. What is the value of AN? On the previous mathematics, you have determined the value of AN.
0.0835.
0.0835. And what is AM?
0.038.
038. Is it 0.038? Okay. So
18. So 0318.
Sir, it's
0318.
sir, এটা তো 0.0625 আছে।
Okay. I will check the value of AM. AM is 1 minus 0.25 whole square. So it becomes minus 1. 0.03175. 0.03175. This is AM. Okay. So M is 0.3, G is 9.8, and what will be the rest of this value? Multiplied it, and you will get the kinetic.
0.05175.
Multiply, and then you will get the formation of Joule kinetic energy in Joule form. Okay. What will be the answer now?
The 0.1521.
0.1521 Joule. Okay, so if you are, or if you have to determine both for kinetic and the potential energy for all of these points A, B, and C, you can easily determine this thing. Okay, let me go for another way, another pattern of this math. In this section, you are given the pendulum's length, but you are not given the perpendicular distance here. You are just given the angle here. One is 10 degrees, another one is 6 degrees. So this is A, this is B, and this is C. And also, you are given just like this, the mass and the length, or the radius of the pendulum. But in this way, if we determine the potential and kinetic energy at point B, C, or A, I just draw some perpendicular, just like the previous one. and then I have to determine or this ON or OM value. So how? In this time, we don't need the value, we don't need to determine the value of CN or BM. Because I make a triangle here, OCN or OBM, so I have an angle here also. I can easily determine the base of this triangle. Suppose if you have to determine UC here, what is the potential energy at point C here? So how we can determine? First, we take the triangle OCN. Suppose it's OCN. And on the OCN triangle, I can say ON as OC cos theta. Because we know that the horizontal component is multiplied by the cos component. It is the cos component. So what is OC here? It's 1 meter. And what is the theta here? It's 10 degrees. So what will be the value of ON? 1 meter into cos 10.
So 0.984.
9843. 9848. 9848. So it's 9848 meter. So easily you can determine ON. So certainly you can also determine AN. It's OA minus ON, or 1 minus 0.9848. So the answer becomes 0.0152. 52 meters.
0152.
Yes. And now UC becomes MGAN. So 0.3 into 9.8 into 0.0152. Multiply all these numbers and tell me the answer.
0.0446.
0.0446. So in this way, we don't need the value of Cn or Bn. We don't need any Pythagoras theorem. We just go for the component here. And with the help of this component, we will determine the rest of the mathematics. Okay. Now, you determine UB, KB. UB and KB in the same manner. Okay, give me the answer. What you have got as OM value and what will be the value of AM. What is the value of OM here? 0.9945.
OM 0.9945.
Yes, 0.9945. And then if I say what is the value of AM, it's 0.00547.
0.0055.
Okay, 0.0055. Now, just plot it as mg into am. You will say it is ub.
Sir, 0.01617.
0.0161. Okay, 0.0161 joule is the answer. 0.0161 joule is the answer for potential energy. Okay. One is done, and now the second one. What is the kinetic energy? So same thing. You know that the kinetic energy is measured from upward to downward direction. So it's mg into nm. And also you have determined the value of an and am. So if you subtract the value of am from an, you will get nm. Just multiply those values and then you will get kb.
Sir, 0.0285 joule.
What is the value of nm?
Sir, 0.0097.
97 multiplied by 3.3 and 9.8. 0.0251 is the kinetic energy. So the answer of kinetic energy at point B is 0.0285. Okay, good. So here today we have discussed the work for energy, the conservation of energy, in fact, in this section. Tomorrow we will go for the power section and we will do some mathematical problems of power. Okay, thank you, boys. That will be today's class. I will stop the meeting now. Thank you. Allah Hafiz.